Very good. Well, first off, let me welcome all of you to the Houston Archeological Society meeting for May 2022. Tonight we have a great program by Dr. Jon Lohse, and I'll just give you a little background. He's a senior associate at Terracon Consultants, and he is also the vice president of the board of directors of the Galt School for Archaeological Research. And he's an affiliated researcher with the anthropology department of Rice University. So Jon is quite prominent, and not only that, he's a 7th generation native Houstonian. So those of us who are also native Houstonians appreciate that. And so without further ado, I'll have Jon come over and start his presentation.
Thank you, Louis. I set this here and kind of promise to not wander. Will that be okay with everybody? Sounds good. Okay. Vote from the online audience. Liz Kuhn says yes, that's fine. So that's what we'll do. All right. I appreciate the invitation to talk to the Houston Archeological Society about this very exciting project. I'm not going to read the title because it's real long, but it's exactly from the cover of the book that that I'm going to kind of talk through. I had the chance to kind of give this presentation last night to the Plains Archaeological Society. It was a real privilege for me. And if there are some mistakes or glitches or whatever, it's because they kept me up too late, but you can blame those guys in the way up north. So I'm here to talk about Calf Creek. And what we have learned about this archaeological horizon, what we mean by that term horizon, all the variability within Calf Creek, where the ideas came from, and maybe some directions for some possible future research. So this is recently published, and recent is 2021. I think it came out in hard copy in December or so. This is what the cover looks like. I don't have copies here to sell you, but if I did, I would encourage you to pick them up. It's not self-promotion. All the proceeds from the sales of the book are being donated to the Native American Scholarship Fund of the Society for American Archaeology. This is one of the things that our colleague and co-editor Don Wyckoff suggested, and of course it's a wonderful idea. This is kind of represents a close to a lifetime body of work for Don and a lot of his colleagues. I was invited to participate in this, right? And so a lot of the research initiatives, a lot of the ideas, a lot of the kind of the founding concepts and observations are by other people. So what I want to do tonight is talk about Calf Creek in the context of how the volume is laid out and the stories that it tells about this particular time period. But I want to kind of be truthful and faithful to the many collaborators and the many presenters and co-authors, people who helped make this project possible, right? And so it really has been a team effort on behalf of a lot of folks. Within this book, which we're very proud of, we cover a lot of topics. It's about 600 pages long, very beautifully illustrated, full color, right? And so we had a nice subvention, bit of support for A&M Press that allowed it to be published in beautiful color. So if you get a copy in your hands, it weighs about 50 pounds or so, but it's worth the effort to tote it around. They have to kind of print it on the heavyweight paper to withhold the color photos. But we talk about dating and chronology building. Several studies are kind of important, geographic and regional distribution studies. We learned a lot about variability within the Calf Creek pattern. There's some effort given to environmental reconstruction. There's a very significant period of time in the Holocene, about the Middle-Holocene. You know, it shows us there's a lot more kind of sharp, high-resolution variability than maybe we would have realized previously. There's some implications from Calf Creek about bison evolution, bison paleoecology. There's a chapter in the book that kind of covers that, but I think there's a lot more really exciting work that can be done with respect to bison and their changes through time. If you like stone tools, like I do, there's a lot of typological and some technological studies. I don't want to put those in kind of a bucket and dismiss them. The technological studies in particular have moved us so far down the line in terms of how we understand Calf Creek. And I'll talk about what I mean by Calf Creek. There's a lot of variability within that that's important to grasp. And we understand that so much better today than we did 10 years ago, or maybe even like 7 years ago. So this is some significant research. The typological studies, I'll kind of cover some of those highlights. it can be a little bit boring for some folks, you know, who get a little bit overwhelmed with stone point types. But we've been able to include some chapters that include or cover the original type specimens that were used to define some of the basic type categories for this. And so there's a lot of kind of historical significance in that part of the volume. When we get into kind of regional variability, there's some heat treating stuff that's incredibly fascinating to talk about and helps us understand Calf Creek mobility, Calf Creek sort of commitment to intensive resource processing, intensive commitment to the production of these beautiful lithic artifacts. And then the last couple of points are kind of covered up by our Zoom bar. So I can't remember exactly what they are, but we'll talk about those two. I've done a lot of collaborative work in my life, in my career. I prefer collaborative research. It makes me better. It kind of pushes me along. I learn a lot. I get more out of that than I put into it, right? And so collaborative archaeology, collaborative research to me is the way to go, certainly for a topic that's as big and complicated as Calf Creek. As I mentioned a minute ago, I was invited to participate in this project by Don Wyckoff and his colleague Margie Duncan. I think we can't really move this a little far, but that's Don on this side, and that's Margie in China on the other side, of course. And they've been studying Calf Creek for a long time. And so in a lot of ways, I'm kind of new to this collaborative community that they've built over time, largely in Oklahoma, but you'll see in a little while that it spills across state lines elsewhere. And the energy, the intellectual energy, the physical energy that they've put into this project over years, and certainly into sort of helping us all collectively see this volume to completion, has been probably one of the greatest sort of sources of professional reward and gratification that I've experienced up to this point. When we talk about collaboration, to me, one of the things that is a best element of the volume are a series of chapters that Don in particular kind of drove, but you'll see in the list of collaborators and co-authors that he's pulled together several professional archaeologists, and a number of avocational folks that he's become colleagues and friends with over his many decades long career, right? And so he kind of really relied on these grassroots collectors and observers and documenters to help him document regionalized patterns of Calf Creek within the larger sphere of the Calf Creek geographic area. And so I think this is, I just want to kind of pause on this for a minute to celebrate really this connection that Don and his community has built and put together. In my view, one of the greatest sort of parts of this book is it really kind of celebrates that collaboration. Another really excellent part of the book, and then I'll stop plugging that, is the beautiful maps that you'll see here, made by our very own Jenny Kimball. So thank you very much, Jenny, for your contributions to the book. Way to go. That's probably the only reason she's here tonight, on the big screen. Okay, so here's a map of the Calf Creek horizon. This is a dotted line around the perimeter, right? And what that means is that this is what we know, kind of, we approximate about the boundaries of where Calf Creek is found. But the truth is that we don't quite. You know, so there's not a lot of Colorado that's covered in there, but you can't complete that arc without capturing the bottom corner. We suspect that they're there, you know, they just really haven't been documented. You should not mistake the blank spaces within this map for places where Calf Creek does not occur, because that's not true. Everywhere within this dash line, you can find Calf Creek points, Calf Creek material culture. But these dots and these site names are just ones that we were able to kind of focus on or include as specific studies or study areas in this volume. You'll also notice, of course, that there are a couple of outliers, one way up in what I guess is North Dakota, one way over here in Utah. So people who are associated with Calf Creek material culture certainly covered this much geography, and they went further than that, right? This much geography, if you're like me, you're wondering, like, how much geography is this exactly? This is the first thing I want to know. It's about 500,000 square miles. And if you kind of compare the volume of that area to any other post-Paleoindian cultural pattern in North America, this is as big as anything else you'll find, right? And so this is Middle-Holocene during the Archaic period. We kind of tend to think of Archaic folks as sort of slow-moving, slowly changing, small regionalized societies or traditions. This is not the case at all. And so Calf Creek really stands out on the map as an exception to a lot of those assumptions. So we talk about the Calf Creek horizon. What a horizon is archaeologically, and I'll talk about this all night long, so hopefully you don't get tired of it. You know, it's a slice of time that's got geographic boundaries, okay? It is defined, we can define the extent of this horizon by the consistency, by the patterning and the similarities of a long list of material culture traits. First and most obvious of those are these basally notched projectile points. So these thin triangular bifaces that were hafted on spears and hafting elements, top illustration, are characterized by those ears that come down and those long basal notches that come from the bottom all the way up, okay? So there are a few other point types, few other point type technologies that have basal notching. None are so well expressed or executed consistently as Calf Creek. And so when we see these kinds of artifacts, like, I recognize that for what it is. In some cases, you can find those ears, the little tangs that are on that hang off in the corner, and recognize them for what they are. It's not easy to do that notching. It's a very risky, very skill dependent exercise. And so, not surprisingly, a lot of people practiced a lot of notching. So one of the types of material kind of patterns that we see on Calf Creek sites and assemblages are these practice pieces. It's like they just practice. And it makes sense, you know, kind of when you think about it, because you can't hunt bison and eat bison all day long. The rest of the time you spend preparing to hunt bison and eat bison, and preparing to do that means learning how to make these deep basal notches. And so these practice pieces, you can find those on sites and you think, well, this is probably characteristic of the Calf Creek material assemblage. This point specimen, I think, came from the Falcon Reservoir area and is a good example of, you know, somebody just kind of dinking around, we assume, notching a point just to kind of get the hang of it. The notching activity is really, really risky. The debitage that comes off of that, those notching flakes, I don't have a picture of those, are characteristic, almost to the point of being diagnostic of this kind of behavior and this kind of lithic industry. And so, like, overshot flakes can be characteristic or diagnostic of Clovis assemblages. In a lot of cases, notching flakes, the debitage itself can be diagnostic of a Calf Creek assemblage. The failure patterns, and Jenny thought this was witchcraft when we talked about it initially, the failure patterns are very distinctive as well. So this whole behavioral package of deep notching is very unique and characteristic. And this break right here is almost unique to Calf Creek points. And so even if you have just a fragment, the squared stem that we see, but this break right here is a failure at this last notching moment. When you see this broken pattern right here, Calf Creek. Okay, so even the failure rates and practices can be patterned as well. All this I've talked about, I want to move through this list a little bit faster, leads to the best sort of expressions of highly skilled knapping. You can kind of cherry pick a lot of parts of the archaeological record, but there was something inherent to Calf Creek technology and cultural behavior that elevated or prioritized or rewarded, I suppose, in some ways, the skilled expression of these knapping complexities and challenges. And I just want to kind of show you one of the best examples probably that I've ever seen of a Calf Creek, a complete Calf Creek point that sort of expresses the symmetry, the regularity, the flaking and so forth. And so highly skilled on times knapping behavior is a diagnostic trait or element of this pattern. Calf Creek horizon is defined, I mentioned a second ago, we'll talk about it a little bit more later, by a close association with bison. So we see Calf Creek hunters, Calf Creek peoples as bison hunters in particular. In some cases, you know, evidence has been found, and this top image is a skull cap of a Bison occidentalis that was recovered from a riverbank, I think near Tulsa, with the Calf Creek point actually embedded at the base of that Orinfor, which is a pretty phenomenal thing. The lower illustration was excavated from a town in the Panhandle called Stinnett. Stinnett, the community, they were digging a pool, a community pool, and when they had the bulldozer pushing away some sediment, bison came out in the dirt, Calf Creek point. Other assemblages, if you're not lucky enough to kind of walk down a riverbank and find a skull cap or be digging a pool and find a bison, that doesn't happen to most of us, I guess. But if you're digging a typical site and there's a lot of bison in there, please be mindful that there may be a Calf Creek component if you don't have any other cultural evidence to help you figure out where you are time-wise. Some of the other kind of characteristic behaviors, a lot of emphasis on heat treating. I'll talk about that in a minute. We do see evidence of materials moving across very long distances, and I'll talk about that as well. Those are characteristic traits of bison hunting cultures. Calf Creek is a good example of that, but there are others, particularly in Paleoindian period, that Calf Creek represents. In this bottom term, caching with a question mark, I'd have a couple slides of that. We're going to see the caching behavior is probably characteristic of Cache Creek, but the truth is we don't know a whole lot about it because we have not yet documented scientifically as many biface caches for Calf Creek times as has been the case for other prehistoric cultures. And so this is just kind of a laundry list of some of the material traits that we find or can see in the field and say, oh, we're on a Calf Creek site. So what's in a name? We've used the term Calf Creek. It's on the cover of the book. The truth is that that term captures a lot of variability. It kind of glosses it. And so it's important to kind of understand what that variability may represent. There's a certain time depth to the evolution of this term as well. In the late 50s, a gentleman named Lee Adams was working in Missouri and found these deeply basally notched dark points. He didn't give them a name or type name at that time, but this is probably the first documented, we think the first documented by science recovery of this kind of material culture. Around the same time in Arkansas, a fellow by the name of Don Dixon excavated some very similar specimens from Calf Creek Cave there in Arkansas. He didn't give that name until about 68 or so, but these are some photos of the type specimens that he recovered. And so Calf Creek, not the first time they were found by Don Dixon, but the first time that they were named in science came from that particular project. And so that's been the label that stays with this technology ever since. We were fortunate enough to have included in our volume an original chapter written by Don Dixon that talks about his work at Calf Creek Cave. It then includes both photos and illustrations of these original type specimens. So these are kind of a couple of examples in the 50s and 60s of where work was going on that recovered examples of this material in good context. Not to be outdone, Texas is also represented in 1960 by Bill Sorrow et al. His work at the Stillhouse Hollow Reservoir in Bell County. His team recovered other specimens that were similar, not exactly the same, but similar. And I've got those circled in red. These are type specimens from Bill Sorrow's work. And he gave them on a provisional basis the name Bell, right, for Bell County. His type description is a little light, right, but it's established in the literature. The name is established in the literature. One of the chapters that we've got included in our volume is a type description for Bell that's a lot more detailed and a lot more kind of robustly illustrated by Elton Pruitt. That's an original study as well that we cherish a lot. So we have Calf Creek, we have Bell. These images on the right-hand side are Andice points from a study that Elton Pruitt published in 1983 in La Tierra Journal, based on a collection that was in existence or had already been gathered up from the Galt site by J.E. Pierce. So Elton hung around the bowels of Tarl and dug these Andice points out, and he described them typologically, metrically, morphologically, and gave them the name Andice from a little village that's just down the road from the Galt site. And so these three names, Calf Creek, Bell, and Andice, for a long time, and still today, kind of primarily dominate what we think about as representative samples or specimens within Calf Creek, right? The truth is, though, that there's more variability than this. We see examples of Bell, Andice, and Calf Creek there. Two other names I can share with you. One is Costat River. I had no idea that there was a thing like Costat River until I started working on this volume project with Don and Margie. These are those specimens on the top row. And you'll see, of course, right away, they're resharpened, broken, worn down, but they have the characteristic basal notches, right? They also have this indentation on that basal margin of the stem. So these define Costat River. And I've got Laguna included with a little asterisk by it. If you follow Turner and Hester and McReynolds et al., you'll know that Laguna is a type name that has been given to this particular point type. If I advance the slide or go back, there we go. One more. Laguna is, they would call Laguna this bottom right red circled one that has the kind of outflaring barbs. Okay, I know this isn't as exciting to some folks. Elton sees those as another example or expression of variability within the Bell category. And so in Elton's chapter, he calls these points Bell, and elsewhere they would be called Laguna. So depending on what side of that typological divide you fall, super exciting stuff, you would say, well, there's another fifth type that represents variability within the Calf Creek area. So going back to our kind of geographic map, this is just kind of a high elevation view of the kinds of typological differences that we see and where those point types can be found or expected. Costat occurs way up there to the north. To my knowledge, doesn't quite overlap, but it probably does with Andice, that black circle. Calf Creek covers a large area, and then Bell extends down here kind of in the southern part of the Calf Creek geography. And I want you all to kind of keep that term in mind, the southern part of the Calf Creek geography, because we're going to come back to it at the very end of the night. Bell points occur all the way down into northern Mexico. Andice points occur all the way to McFadden Beach, and every HAS member knows that McFadden Beach is on the shoreline and represents Gulf Plain, Gulf coastal margin hunting a long time ago. And so you can extend the Andice range all the way out into what's now submerged coastal shelf that's been inundated by rising sea levels. So these distribution maps, of course, they go a little bit farther abroad than what's shown here. But this is just a little bit of a glimpse of the typological variability and where those occur. So what's the relationship within a Calf Creek series? And this series, this term series, is a kind of a classification unit that includes two or more types that are pretty similar morphologically and technologically. So we have Bell, Andice, Calf Creek, Costat River, Laguna, if you believe in that. What's the relationship within this series? For a long time, folks hypothesized, I think, that they were just simply one point type. So this is the difference between a lumper and a splitter, right? And that they just existed in different stages of being resharpened and kind of worn down. So they would all have originated large, then after some use, they get to middle size, and after more use, they get to a small size, and then they get discarded. We know now this is a lot of the technological work. So it's not simply typological, but it's technological by Sergio Ayala has really pushed this envelope farther probably than anybody thought it could be pushed. They do not overlap. These are stem measurements. Bell and Andice do not overlap. The Calf Creek kind of in the middle. There's a little bit of overlap in the center in terms of the stem dimensions. But with Sergio's work, looking at notching behavior, looking at sort of the strategies for beginning those notches and the basal preparation techniques for each of these three types, the biface thinning patterns for each of these three types, really kind of helped us define or help demonstrate that there's different mental templates, there's different technological approaches, and there's different outcomes, right? And so from step one, you cannot get from an Andice point to a Bell point, right? They'll never kind of overlap. So these are different outcomes intended from the beginning of the production sequences. So this really does kind of help cement the concept of lots of variability, cultural differences within the Calf Creek series and Calf Creek geography. We don't really know much about the chronological implications for these three different types. So we just kind of lump them within this Calf Creek series and we talk about them within a single type period. But it would be fascinating at some point to kind of know one is mildly earlier than another. So today what we kind of understand, again, just to kind of focus on this term horizon, within the geography, we see consistency in debitage, we see consistency in biface manufacture, we see consistency in heat treating, we see consistency in bison reliance, all these other things are on a trait list. All of those are not identical and not the same, but they're the same enough within the space that we can archaeologically call that a horizon. So this is a time marker wherever you are in Oklahoma. If you are kind of lost in time, but you find some Calf Creek material, you're like, I know exactly where I am with respect to the cultural sequence in this area. So I think one of the some of the progress that comes from the volume is really helping to kind of nail down this sort of time-space unit in terms of archaeological patterns and history. So that's that. Hopefully that's all clear enough. I want to talk for just a little bit about some of the behavioral sort of impressive points about Calf Creek, if you will. So we'll talk about heat treating. And this discussion is going to be based on two sites in particular, Grouse Creek, which is in very southern Kansas, and the Kubik site, which is in very northern Arkansas. And both of them occur at the southern end of the Flint Hills region, beautifully illustrated in rosy pink. Both sites, of course, excavated by Don and Margie and their colleagues. And I would say that these two sites are among the most significant sites that we have in Calf Creek research and scholarship for different kinds of reasons. I doubt we'll ever see a site like Grouse Creek again. It's simply amazing. But the Kubik site was incredibly important because for so long, we saw these points and we saw the related material assemblages. We didn't really have much stratigraphy. We didn't have very much primary context. We had very little dating that people were kind of confident in. But starting in about 1996, Don and Margie and some of their colleagues from Oklahoma conducted a series of 2x2 meter units and found Calf Creek in sort of stratified context. There's a little bit of material above and a little bit of material below. But we're able to kind of record and document some of these primary deposits. This is an example or a photo of what they call feature 5, or what they recorded as feature 5. There's a kind of a cluster or a concentration of knapping debris. So these are the flakes from feature 5, over 380 thinning flakes. And you'll notice that they're all, this is true color. So this is one of the reasons that it was so important for us to publish this volume in color, rosy kind of pink reddish color. And this is a distinctive outcome of deliberate exposure to heat. And so knappers would have heated these stones prior to knapping or reducing the bifaces. The controlled exposure to heat has the effect of removing moisture from the stone, and it makes the consistency a little bit more homogeneous and similar, and it makes it easier to control flaking. So it's a deliberate technique that's used to kind of enhance or make more successful, particularly risky flaking behaviors. Unfortunately, below the zoom bar, they had a couple of dates, 3 dates, I think, from the Kubik site. And so for the first time, we're able to kind of nail down Calf Creek, not conclusively, but get a kind of rangefinder dates for what this is in time period. If you calibrate these, they're between about 5,700 and 6,000 calendar years ago, but I'll show you that again here in a second. So that's Kubik. Just go about 25 kilometers to the north. The Grouse Creek collection, which is collected over the period of about a decade or so in the early 2000s, came to attention courtesy of a gentleman named Travis Long, who was working on a road crew, and saw a road that had been sort of washed over by flood deposits, kind of washing through this field. And so as they cleared it, there's a lot of chipstone artifacts that were in the material kind of washing across the road. And so the site was surface collected over about a 10-year period. And during that period, they recovered over 800 artifacts that are associated with Calf Creek time periods and distinctive of Calf Creek technology. Within that remarkable collection is about 324 points, which is probably the largest Calf Creek assemblage that we're ever going to see. And I'm going to show you a lot of pictures of different sort of stages of heat treating. But I think it's important before we get to that to kind of understand the magnitude of a site like Grouse Creek and what it means. So it's in a kind of a chert outcrop area, but the points are broken and reused. And so what we see in the bifaces is retooling. So this is a base camp retooling station that people came back to over and over again. The exotic material that's within the assemblage is just kind of in trace amounts. So it's about 5% or less of the assemblage, but comes from as far away as 800 kilometers away. So this table from chapter 15 kind of breaks all that down by source, artifact count, and distance from source to where it was found. You can see some central Texas material is sort of the winner at over 800 kilometers away. So even though there's a lithic rich area where Grouse Creek occurs, they still are bringing stuff in from the Ozarks, from Missouri, from central Texas, from the Panhandle, from all these kind of other areas. So this is intended to kind of go through this series sort of quickly. Each of these show you examples of color variation that have been documented and inferred to have come from 25-degree heating intervals. So this is from 525 to 550 degrees. We go 550 to 575, but just kind of note different stages of reduction in the bifaces. And I also like to look at different sort of patterns of wear and breakage from the stem points themselves up to 600, 625 degrees. We understand, or we're able to kind of reconstruct these ranges, these temperature ranges, all the way up to 700 degrees, 725 degrees. Okay, so this is reconstructed behavior based on, and even recognize some heating failures, right? Based on a series of controlled heating experiments that a gentleman named Paul Benefield conducted with materials. He also replicated a lot of the Calf Creek bifaces, but he spent a lot of time analyzing Grouse Creek material, recording very carefully and deliberately the color variability, the relationship between color variation and reduction phase or stage by also material type. in his experiments, sort of concluded the best optimal temperature ranges, because all this material is a little bit different geologically and chemically. But if you're to heat treat all the different materials that you find at Grouse Creek, what would be the optimal temperature ranges to heat that material to? And so he kind of used those experiments to interpret all the color variability from the Grouse Creek stuff. One of the things that sort of strikes me the most about the study, the sort of series of studies that contributes to these conclusions, is the intensity of the commitment, the depth of commitment to treating material by heating it in a controlled fashion. So you've got to very carefully raise the temperature, you've got to maintain that temperature for a period of time, and you've got to very carefully control how that cooking event cools off. That can take up to 40 continuous hours, okay, in controlled circumstances. And all of this, it consumes an incredible amount of wood. And if you live on the grassy plains today, I don't know where you go to get a lot of wood to cook all this jerk that's coming from both nearby and far away. But the takeaway message is that the level of sophistication and understanding of the requirements for preparing jerk to this level of degree is incredible and surprising to anybody. And the commitment to finding the natural resources that become part of that technological behavior are also pretty astounding. So very impressive to me at any rate. Caching. I had to show this because these are 6 of the most amazing artifacts that I've ever had the privilege to see in photograph. I'd ever seen them in person in my life. The biggest one is over 20 centimeters long. And if you're a flint knapper, to break or to make a 20 centimeter long biface without breaking it is incredibly difficult. These are all examples of andice technology, andice flaking, andice sort of entry to these basal channels or flakes, notches, if you will. Sergio Ayala, in his sort of research about Calf Creek behavior, notching, biface reduction, he combed state after state after state, went through collection after collection after collection, and beating the bushes, came across what's called the Denton Creek cache from way up in north central Texas. I don't know if you can see that very clearly on the top right part of that. It's right there on the Oklahoma border, pretty far away from any chert outcrop. These you'll see are a little bit resharpened, a little bit kind of worn at the distal end. A couple of them have some pretty clear, obvious notches that are along the side margins, the lateral margins of those blades. This is not utilitarian behavior. It's difficult for us to kind of reconstruct ideology and belief systems 6,000 years ago. But there's a good chance that this is giving us some kind of a window into people's mind view and mindset and belief systems into the way prehistoric past. This is only the second. I'm only going to talk about 2 different caches, but this is the second of those. This comes from Wilson County, kind of down in south central Texas, also a long way from large chert outcrops, right? And so what we see from this caching behavior is a kind of a commitment to embedding in the earth, right? Lithic resources that have been worked down to a certain or reduced down to a certain degree, probably with a goal in mind of coming back to those places, right? And so these are characteristic of andice biface production. There's a lot of attention that may not be completely obvious in these photos, but there's a lot of attention to the basal preparation, the thinning of these basal margins that allows those notches to kind of be initiated successfully. But this caching event down in Wilson County is a good example of Calf Creek behavior and mobility away from church sources. Dating, okay? So this is a topic that I care a lot about, but I'll try to kind of rein it in. Placing Calf Creek in time, of course, is a challenge and a goal for archaeologists. Over time, as chronologies got put together, Calf Creek got slotted in, right? And time assignments that were set aside for Calf Creek were as much as about 1,000 years long in some of our earlier models. And we would see this as kind of coarse grained. There's several reasons for approximately 1,000-year guesstimate, even something like a 500 or 700-year estimate. I call those long chronologies, okay? To assume or to imagine that culture change happens so slowly that you've got a 500-year to 1,000-year period where not much is changing, to me kind of boggles the mind, right? And so I began to wonder, like, if we took a different approach to dating Calf Creek, could we change these long chronologies to short chronologies? it makes sense that we get to these kind of conclusions, but for archaeologists, interested in kind of addressing old questions and coming up with new answers, to me, this is one kind of an easy way for me to participate and make some contributions to Calf Creek work. And so the approach that we took to kind of address this issue was to set aside dating by association, to pay less attention to kind of compressed or intermixed assemblages where the stratigraphic resolution wasn't all that great, but nevertheless, there's a lot of Calf Creek material coming out, and instead focus on directly dating short-lived organic remains like nutshells, directly dating bison. I don't want to talk a lot about dating bison in the kind of the chemical requirements and pre-treating requirements of that. But when we shifted a focus away from just accepting dating by association to directly dating and precision dating select remains, it allowed us to kind of really rebuild this Calf Creek chronology. And so building a chronology requires or allowed us to kind of follow what I call a preferred sample selection hierarchy for precise dating. The goal is precise dating, not generalized dating. So it includes specially purified, directly dated bison remains. Like I said a second ago, short-lived botanical remains like burned nutshell from the Kubik site, for instance, that are unambiguously associated with bison. And then you get to kind of some second-order sample choices and some third-order sample choices. And if you have a lot of samples to choose from, my suggestion would be to eliminate dates that come from like category 3 altogether, if you can afford to do so, right? And so all that other kind of low order stuff, if you eliminate that from your models, what you can do is kind of tighten up the results from your dating. And so that's what we've done. There's only 21 dates. You can't see that number here because it's behind the bar, but this graph shows you 21 dates that are kind of lifted up because of our sample selection protocols, okay? And they are all consistently between, blocked out by Zoom, 6,000 calendar years ago and about 5,700 calendar years ago, without exception, okay? So 21 is not a big number. I wish we had more. We need more dates. It's not a big sample for 500,000 square miles, but directly dated bison, unambiguously associated, charcoal in Calf Creek assemblages, all within this 250 year time range. The other thing that's important to note about this is that to the south of the the Calf Creek geography, those dates are a little bit older than they are to the north. Again, we don't have a lot of samples, right? And so this work has a long way to go, but the dates appear to be a little bit older and they're all consistently within this narrow time range. Within the volume is a really neat chapter from a study in Arkansas. There was a data recovery project done by a company called Flat Earth Archaeology. And this chapter was lead authored by a gentleman named Shaheen Chowdhury. There were 2 sites, one on either side of a creek that were data recovered in advance of an Arkansas DOT project. And you can see it up there in Benton County. They published a couple of dates. We could use, of course, all the dates that we can get from secure Calf Creek components, but one of them came from feature 18, which looks a lot like, to me, feature 5 from Kubik, right? This kind of dense concentration of napping debris. And there are a couple of dates that they associate with their Calf Creek component. These are uncalibrated dates with the calibrated ranges in parentheses. Again, fall perfectly within this range that we've built with these other 21 samples that were sort of lifted up from priority screening. That red bar is the couple of days from the Northwest Arkansas area. So the consistency of our Calf Creek chronology to me is really impressive and really important. And it's important that when you kind of use this sample selection criteria, all the reliable dates, they don't get older, they don't really touch 6,000 years ago, and none of them go sort of past 5,700 years, calendar years ago. So we're going to land this plane here in a minute. I want to talk about a hypothesis. This is sort of grand finale of the volume. Hypothesis for the origins of Calf Creek and how can we make sense of rapid culture change so far into the past that encompasses such a large area, right? So when you think about the capacity for prehistoric peoples to rapidly change their cultural practices, that's a lot for archaeologists to get their minds around. We know from radiocarbon data that it was a very brief period, and we know from isotope data, stable isotope, carbon and nitrogen isotope, that it was a very cold and a very dry period. In this graph on the right-hand side, the big black plus is isotope data from my sample of Calf Creek bison samples. And the further over here to me, you get along the horizontal axis, the colder it is, and the higher you get on the vertical axis, the drier it is. So that's nitrogen along the vertical axis, stable carbon along the horizontal axis. And those little light blue C's, those are samples that Casey Carlson and Lee Bement have run and published from a site in Oklahoma called the Cooper site, which is a Folsom site. Okay, so they get really lucky, the bison sites that they get in Oklahoma. They've got multiple Folsom sites and even some Clovis sites. All those blue sites are Paleoindian bison samples, and the Calf Creek material plots exactly in the middle. So when you talk about climate for Calf Creek times, this isn't warm, it's not wet, it's cold and dry, exactly like Folsom times, okay? We know that from isotope data. I don't want you to get lost in this graph, but the thing to note is these green bars that probably you can barely see are globally defined. So from speleothem records, from pollen data, from lake core studies around the world, they consistently define these periods of cold climate events, right? And one begins almost exactly at 6,000 years ago. And this is what we see in our Calf Creek times, right? And so you can take some of the global climate information, you can take our isotope data and our radiocarbon data and kind of begin to build a model. During rapid cold events, the cold temperatures, they come down from the ice caps and they go to the mid latitudes, right? That's where the cold energy and cold air is. And when the earth warms, it happens reverse. And so on the onset of one of these cold events, I want you to project your mind back 6,000 years ago. Say, well, I'm in Texas, it's pretty good. It's 6,000 years ago, 5,999 years ago, it's pretty cold, right? So that cold air is coming down. One of the things that happens a little while later, and this was a study that I wish we had in our volume by like a grass kind of plains prairie ecologist. How long after the cold climate comes does grass habitat, grassland habitat migrate southwards to follow those cold environments? That's the second thing that happens. The third thing that happens is the bison chase the grass, right? And so this is a model, and there's a lot of work that needs to be done in the intervening geographies up and down the grassy plains. But the idea is that at the onset of this global cold period, 6,000 years ago, the grasslands changed and the bison changed. The next thing that happened, can anybody take a guess? Hunters encountering bison changed their behavior as well. And so this image, the question is like, well, where does Calf Creek technology come from? And we looked around our geography, right? We looked around the Calf Creek geography. The best example that I can think of, the best sort of possible ancestor or precursor to Calf Creek is found in the southern part of the Calf Creek geography. What Tom Hester calls as a corner notch tradition, and that includes different types like Merrill, Bandy, Martindale, where the bases are notched, but from the corner angles become basal notch traditions. It's a simple adjustment, right? And those transitions happen. In some cases, you can find like Bandy and Bell intermixed, Merrill points and Bell intermixed in the same kind of archaeological assemblage. And so it's a model, right? And what we lack is the stratigraphic resolution across multiple sites to test this out. But my guess is that there's a pre-existing lithic tradition or cultural tradition that was in place when bison came into the southern end of our region. A slight adjustment was made. Let me come back to that. And then those technological patterns and adjustments went back upstream, if you will, back from south to north across the rest of the Calf Creek area. So I'm going to go back a slide, exploring for other possible ancestors. This is a point type called Munker's Creek. Munker's Creek, also another type I never knew about before this study. A chapter in the volume by a gentleman named Michael Stites dates Munker's Creek points. They are exactly before the Calf Creek interval. Again, obscured by the bar. Have nothing to do with Calf Creek biface technology. There's no shoulders, there's no barbs, there's a stem, but other than that, they don't look anything like Calf Creek points. And so as a possible candidate, as a candidate for precursor to Calf Creek, I would say, eh. So the best case are these corner notch traditions that occur in the southern part of the Calf Creek area. And then those changes spread or diffused from south to north. So it's a model. We kind of talked about that in our volume production. Don's from Oklahoma, Margie's from Oklahoma, that's to the north of Texas, to the south. That's where a lot of the Calf Creek work was done. I thought they would get mad at me and kind of shout me down, but they're very gracious and they didn't. I hope that they're okay with all that stuff, but we'll see. So conclusions, of course, thanks a lot for y'all's patience sitting through this. But we see Calf Creek today. I learned a whole lot more about it than I ever thought was possible to learn. But we can see Calf Creek as a very widespread, internally consistent, but with important variability internally. Bison-focused horizon. Even though it postdates Paleoindian complexes by thousands of years, I see this as kind of like Paleoindian, kind of behavior, right? So there's large, widespread mobility. There's exquisite kind of high risk flint knapping that defines their behavior. One of the things that probably the most important, impactful contribution that this collection of studies makes is an example of the power of collaboration, between the professional community and avocationals, locals, grassroots documenters, site stewards, resource sort of protectors, and so forth. And so the volume is really a testament to Don and Margie's work over a long period of time building those networks and reaching out to folks. And so on behalf of them, I would say thank you, and of course for you all this evening, your online audience, thank you as well for inviting me to speak tonight.
Those areas, were they all used on spears and also bow and arrows later on? And also, were they ever used to fight other people?
So we imagine that no Calf Creek dart point or projectile was ever used with a bow and arrow. The mass is too large and it just won't fly, right? We don't have any evidence in North America for bow and arrow technology at this time period, 6,000 years ago, 5,700 years ago. So the answer to the first part of your question, almost certainly they were hafted onto spears that were propelled, with an atlatl or something like that. Interpersonal violence during Calf Creek times. What do I know about that? I heard a story once about a site in Kansas that had a couple of human burials in it. Whether those represent violence or just simply people passing away, I don't know, but we can't talk about, we don't have any evidence of people interacting violently with each other. But I imagine, I'm curious about the nature of these interactions, that you have bison hunters that are now traveling further afield than they were previously. They're coming into other people's ranges and territories, and those social interactions are kind of picking up in frequency. So how those were negotiated is a pretty interesting topic. Yes, ma'am.
One of the illustrations showed the bison horns were kind of curved. Were you trying to show that what climate change also affected the formation of the horns on bison?
It's a great question. And I kind of alluded to this at the beginning, but I forgot to get back to it at this point. This time period, 6,000 years ago, plus or minus 1,000 years or so, is pretty important in the evolution of the bison in the New World. We moved from bison antiquus, which we associate with the Pleistocene, to this intermediate sort of species, Bison occidentalis, that precedes bison or our modern bison. And this illustration about the changing curvature of the horns shows those three steps, if you will. The ones that are most horizontal are the antiquus, the occidentalis is the intermediate step, and then the bison are the most curved up. I'm convinced, but I think a lot more work needs to be done to kind of talk about bison paleoecology and bison evolution in the context of the 6,000-year-old cold event and bison migrations from north to south. What happened to those population dynamics, that kind of contributed to the evolution from antiquus to occidentalis, and then from occidentalis to bison. The 6,000-year time period, I think, is pretty important to that. But the answer to your question, that's what the differences in horn curvature reflect. The lateral ones are antiquus, the intermediate ones are the occidentalis. I'm going to get through this, right? And then the last one is the bison. We don't have a lot of examples of Calf Creek context bison horn curvature, but the ones that we do all show this intermediate phase. They're all occidentalis.
What did they use their horns for? Was it for digging in the ground, or was it for like fighting amongst themselves?
Bison, I imagine that the mass of their head, as I understand it today, so I'm not a bison ecologist, although I wish I was. Sorry, the mass of the head, is useful in the winter season for kind of burrowing and plowing through the heavy snow drifts to find the little rooting grasses that exist down there. the role of horn matter in that, I don't really know. You know, I think probably the answer to that question is deep in, you know, mammal evolution and ecology. Why they changed curvature wise, I don't really know the answer to that. So how bison use their horns, but it's related to kind of their behavior as a foraging mammal, an ungulate on the plains, the grassy plains. Yes, Jenny.
What do you know about technological benefit to a fatal notch point versus a side notch or corner notch point for bison?
I don't know is one answer. I think a possible explanation has to do with sort of aligning the momentum of the point with the haft element and the spear haft behind it, right? If you get all those elements kind of in line with the momentum of the projectile, I think you may increase the stability. There's a theory that I think Elton has shared, that the fragile nature of the ears is deliberate, and the broad triangular morphology of those points is deliberate, and they cause damage going in, and it's okay if the ears break off, because the point is to inflict damage on this prey animal, right? And there are some design similarities between this part of Calf Creek, or this kind of element to Calf Creek design, and later bifaces like Castroville that are also very closely associated with bison hunting. And so they're separated by, a couple thousand years at least, but you see kind of a return to broad, thin, wide, triangular forms with basal ears. So that's a possibility as well. But why the corner notched forms would not have worked, I can't really say. I think it's probably not that they couldn't have worked, because Marcus points are kind of corner notched and they're also associated with bison. So there was just a kind of a preference to shift to this mode is one way to think about it. Yes, sir.
In the Houston area, of course, there were bison in early historic, going back to late prehistoric time, and a time when it was humid. And so I'm wondering, is it a different model that brought the bison down then than Calf Creek?
Nope, it's not. So this graph, I want to kind of point to the top left part of it, is the isotope data with the radiocarbon data with the global cold period data. Okay, so it's a little bit of a complicated image to have only black and gray, right? But I want you to see kind of the global cold periods as those gray vertical bars, and the black rectangles are precipitation as reconstructed from the nitrogen isotopes. The gray rectangles are the mean annual temperatures as reconstructed from the carbon isotope values. Okay, are you seeing that right? And so what you see is Calf Creek, late Archaic 1 and 2, which is Castroville, Montel, Marcus, and then at the far end is the Little Ice Age, right? And when we were visiting before the meeting started up, I talked about in the very southeast margin of Texas, the difference between the early Little Ice Age and the late Little Ice Age. What you're asking about is the late Little Ice Age, right? Historic times backwards a little bit. The early part of the late Ice Age would be, or the Little Ice Age would be, AD 1250, 1300. What we're talking about is 1600. The bison that were described by Jill Toole and the other European explorers, right? This is what we're talking about. And you can see mean annual temperature is a little bit colder than Calf Creek times. Calf Creek times are about as cold as Folsom times. And so the intensity of the Little Ice Age is pretty significant, but the precipitation data, as you said, are different. And so I think the key variable when we're looking at climate is not necessarily the precipitation, it's the temperature.
No.
We can talk about that all night long if you want to, or we can just go to bed. Anything else, anybody?
John, you want to check and see if there's any questions on the Zoom feed?
I don't know.
Or not, that's fine.
Liz says, y'all got questions? Sarah will get them in.
Yeah.
Jimmy says howdy to everyone.
Thanks, Jimmy.
Yeah, right.
Okay, thank you very much.
Yeah, no.
Really fascinating.
Thank you. I appreciate that.
So, what a interesting lecture. So that'll be the end of our program. I want to thank Jon one more time, and we'll see you not at field school. We'll see you back here in July. So stay tuned.